Hi all, let's discuss about tabular data set. So we are going to discuss about advanced dimensionality reduction using tabular data set. So for that, along with that, we're going to discuss about multiple techniques like TSNE, PCA, UMAP, autoencoders, and more. So we'll use some powerful Python libraries like Plotly, UMapLearn, and TensorFlow. So let's get started. We have to import or install the required libraries and then load the dataset. For the dataset, I'm going to use student depression dataset. So which contains numerical features like age, academic pressure, financial stress. So after loading the dataset, we're gonna work on advanced dimensionality reduction on numerical columns. So let's move on to pre-processing it. So to prepare data for advanced dimensionality reduction, we'll first select the numerical columns and then standardize the data to ensure all features have the same scale. This is important because most dimensionality reduction techniques are sensitive to the scale of data. So since now data is ready, we are going to split into train and test. To evaluate our models, we'll split the dataset into training and testing. This is a standard step in most of the machine learning workflows. So we'll use 80% of the data for training and 24% for testing. So now let's move on to applying dimensionality reduction techniques. So let's start with LLA, which stands for locally linear embedding. So LLE works by preserving local relationships in data and it's great for capturing the structure of nonlinear data set. So this is the structure of our data set component wise. And now let's look at TSNE. One of the most popular techniques for visualizing high dimensionality data in 2D form. And isomap is another method that focuses preserving the global structuring of data. And coming to UMAP, UMAP is the fast and efficient algorithms that works well for both visualization and downstream machine learning tasks. So here how you can do it. So we are gonna do multidimensional scaling, and then we are gonna do PCA, principal component analysis. This is the randomized PCA analysis, and we are gonna apply kernel PCA. So this is the component versus component 2 graph, and so finally, so these are the results of factory analysis. So finally, the autoencoders, so which are a neural network based approach to dimensionality reduction. So here's how we train and define, encode and decode them. So once the techniques are applied, let's compare the results visually. So these are the results of autoencoder, and let's compare these two techniques, LLE versus UMAP. So you can see the component versus component 2, and let's visualize it 3D. So this is the 3D visualization of principal component analysis, and plotting with Plotly, you can see how the features are distributed across the graph. So that's it. Thank you.